Alright, today we're going to go ahead and learn how to write up our physics homework. So in physics class we have a really concrete way to write up our homework, especially when we're doing tough math problems. So to do this, we're not going to do tough math problems. We're going to start with just one nice equation you've used in your math classes before. Let's do this up here first. The equation we're going to use is distance is equal to average velocity times time. So distance, we'll just use the symbol d. Average velocity, we'll use the symbol v, and then time is t. Distance, we're going to measure in meters. So if you think like somebody who's in track, when they run around the track, how far do they go? 200 meters, or 400 meters, or 100 meters. Average velocity then is going to be in meters per second, and then time is going to be in seconds. So in physics we tend to use meters, meters per second, and seconds for time. Alright, the first one, and this is a real life problem. It says, number 1, in the 2008 Beijing Olympics, Usain Bolt set an Olympic record by running with an average velocity of 10.363 meters per second. That's 23.1 miles per hour. That's pretty fast, for a time of 19.30 seconds. So as I read these physics problems, or if I'm reading a math problem, I tend to underline the numbers. And so right here they've given us the average velocity, which is 10.363 meters per second. And they've also given us the time of 19.30 seconds. And then what they're asking for is how far did he run during this time. So when we write up our physics homework, we always, when we're doing a math problem, or a problem that has numbers in it, we always write the following words. We write given, want, an equation, because we want a concrete way to organize our thoughts. This problem's not bad. It's using one equation, but as we get into more complicated things, we always want to attack it kind of the same way. It's kind of like if you're playing an easy team in a sport, you still do all the fundamentals as you do against a hard team. So for example, if you're playing an easy team, it's not like you're going to go out there and forget how to field a ground ball or go easy on them. You want to use the same technique every time you do a physics problem, just like when you're a golfer, you use the same technique with your swing every time you swing. So this is an easier problem, but let's try it out. Average velocity, we're looking here, so we're going to say V equals, let's go with the blue pen, V equals 10.363 meters per second. And it says that he ran this in a time of 19.30 seconds, so we'll say t equals 19.30 seconds. And then it says we want how far, so we want the distance that he ran. So if you look up here, we're looking for d. And for this assignment we only have one equation, so we're going to write down that equation, which says d equals velocity times time. Alright, so the last step, we always write the equation we're using, and then the last step is plugging in our numbers. So we're going to say distance equals v times t. So our velocity is going to be 10.363 meters per second. And then notice I wrote the number with the units after it. We always put units on our numbers in physics. And then time is 19.30 seconds. And the reason we put units on is because if you look here, we have seconds on the bottom, we have seconds on the top, so the seconds cancel, and it helps us to know that our final answer is going to be in meters, which makes sense because our final answer is going to be a distance. If you crunch these, let's see what we get. We should get about 200 meters. Alright, so there's our work, and now the last step, once we have a final answer, we always write our final answer with the units on there, and then we box it up. So that lets your physics teacher know their final answer is 200 meters. Now when I grade this, or say this was a test, the first thing I'm going to do is I'm going to look at your final answer and see if you got it right. And I'm like, okay, they got it right. Now let's see if they went through the right steps to show me how they got it right. If this were a 5-point problem, we would be right now 5 out of 5, feeling good. If we made a mistake, so say we got nervous on the test and we did all this work right, and then the last step we maybe just typed in our calculator wrong, say that we accidentally divided them maybe. If you get the wrong answer but you showed me all the right work, I'm not going to go 0 for 5 on you, we're going to lose 1 point. So this would be 4 out of 5. So that's the benefit. When you show all your steps like this, it shows me how you're thinking. That's what I am concerned with. I want to make sure that you identified velocity and time, and you know you're looking for distance. And so you kind of get a point for doing each step. And so that means if you made a little silly mistake on the last step, you don't lose all 5 points, you'd lose a point. But you do have to have all this work shown. Alright, so we're 5 out of 5. We're feeling good. On to number 2. It says number 2. During his 200-meter race from question 1, did Usain Bolt always travel at 23.1 miles per hour? And we can say, no, he obviously didn't always travel at 23.1 miles per hour because he started at 0. So I'm going to write no. And if this is a 2-point question, which a question like this would be, we want to go 2 for 2. Right now we're not 2 for 2 because in physics we always have to explain our thought process. So I have to explain why I put no. He didn't always run at this speed or this velocity. So I'm going to say no. He started at 0 miles per hour and accelerated to a higher speed or higher velocity. So we say our answer, no, and then we explain why, and then we go 2 for 2. If you would have just put no, you'd be 1 for 2. And if you left the blank, you'd be 0 for 2. Number 3. Hey, we're halfway. Number 3 says, later in the Beijing Olympics, Usain Bolt set the world record in the 100-meter race. If Usain ran with an average velocity of 10.38 meters per second, calculate how long it took him to run this race. So after I read the question, I go back and I underline what's given. So they give us a 100-meter race. That's the race he's running. And they set an average velocity of 10.38 meters per second. Alright, and then it says calculate how long. So they're telling us calculate, this is what we're calculating right here, how long it took him to run this race. Alright, before I do it this time, you've seen how we do the physics format given want. Go ahead and try it out. So I'll write the words out over here for you. Given, want, equation, and go ahead and hit pause and then fill them out, and then when you think you got them right, hit play and see if you're right. Alright, so let's go ahead and look at this one. He's running a 100-meter race. So we see that it's meters, that's why the units are so important, because that tells us what that is. So that means that that's going to be his distance. That's how far he's running. It says if Usain ran with an average velocity of 10.38 meters per second, so that's going to be average velocity, or V, 10.38 meters per second. Calculate how long it took him to run his race. Well, we know from our equation up top there that we have D, we have V. We must be looking for T, or time. That's how long. So we say we want time. We only have one equation, so let's write it down. D equals V times T. Now there's a little trick on this one, because you notice our equation's solved, so D equals velocity times time. But we want an equation that has time equal to something. So for a problem like this, we're going to add an extra step, and that extra step is called our algebra step. In math class, and there's nothing wrong with this in math class, but you just plug your numbers in. So we'd plug the 100 meters in there, we'd plug the velocity in here, and then we'd solve for t. But physics students do not do that. What we do is we do our algebra before we plug the numbers, and research has found that you make less mistakes that way. So what I'm going to say is we want to solve this equation for t, or for time. So I'm going to go ahead and write it down one more time. If we look here, we want to solve this equation for time. Well, right now velocity is being multiplied by time, so we want to undo the multiplying, so we're going to divide both sides by v. So our equation then is going to be t equals d over v. And you're like, oh, that wasn't too bad. Well, it gets more complicated throughout the year. We got time equals distance over velocity. So there's our equation. Our last step then is plug in numbers. And I write down the equation that I'm using. Alright, little side note here. I'm doing my homework in pen. Alright? That's just so you can see it better on the camera. If you're doing physics homework, you should be using pencil. just because if you make a mistake, you don't have a whole bunch of crossouts. Alright, so T equals D over V. However, if you're taking physics notes, I say go out and buy some of these G2 gel rollers because they're amazing. You got to invest in high quality pens and pencils in physics class. We have D over V. So we're going to go ahead and plug our numbers in with 100 meters over velocity 10.38 meters per second. Go ahead and crunch those, and let's see what I got. I got 9.63 seconds. How do I know it's seconds? Well, if we look over here, we wrote our units down. We have meters, and the meters cancel, and then we're left over in time as seconds. We're not done yet. We got to box our answer. So the final step would be T equals 9.63 seconds. Some people might be doubters out there and they're like, man, look at all that work for one problem. And it was an easier problem, but we're going to get tougher problems. We're just showing you the thought process that we want in these problems. So if we can do this on an easy problem, we should be able to do it on a tougher one, right? Now, the last one is a tougher problem. So we worked our physics format, we call it, the give and want equation, on some easier ones. And now I threw us a tougher one. It says, number 4, calculate the de Broglie wavelength of an automobile that has a mass of 1,000 kilograms and travels at a velocity of 100 meters per second. Remember that Planck's constant h equals 6.6 times 10 to the minus 34th Js. In order to solve this problem, you'll have to use the classical relation between velocity and momentum. This problem in no way relates to that equation at the top of this page. I threw this one on here just to show you when we have a tougher problem, how we can attack it. You might be asking yourself, where did Mr. Laurent even find this problem? I'll tell you where. I just went over to my physics bookshelf and I went and picked up my college physics book. So this would be a sophomore level physics class. I took it in the spring of my sophomore year over at St. Thomas. And I wanted to show you that there's no reason why we know how to do a problem like this, but that doesn't mean we should leave this question blank. And now using our physics strategy, the give and want equation, we can go ahead and try it. So what I want you to do is this. I want you to write the words given. If we leave it blank right now, we're going 0 for 5, because if it's a 5-point problem, we don't want to do that. So we're going to start this up by just going back to what we know, which is we always write given, want, an equation, and then I want you to reread the problem and underline what's given. And so what I'll say is go ahead and pause it now and try to do the give and want by yourself, and then when you think you have it, the given and the want, go ahead and hit play and see if you're right. Alright, so go ahead and pause it right now, try it for yourself. Alright, we're back. It says we have an automobile that has a mass of 1,000 kilograms. So I'm going to underline what they give us. Mass, 1,000 kilograms. And then I'm going to write it down. Mass, we'll use the symbol M. And it's 1,000 kilograms, kg. They tell us some more information. It travels, this automobile is traveling at a velocity of 100 meters per second. So velocity, we know the symbol for that's v, so we'll say 100 meters per second. And then it tells us, remember Planck's constant, h equals 6.6 times 10 to the minus 34th joule seconds, or I'm sorry, Js. So you might not know what that necessarily means, but we write it down because it's something that they gave us. It's one of our givens. Minus 34 Js. Okay, those are our 3 givens. And then we have to figure out what they want. Well, from our other problems, whenever they said calculate before, they'd say calculate distance or calculate time. That's what they want. So in this case, they're saying calculate the de Broglie wavelength of an automobile. You might not know what symbol that is or what they're talking about, but we know what it is they want, so let's just write it down. They want us to calculate the de Broglie wavelength of an automobile. Okay? And at this point, that's all we can do, because this equation is going to be confusing and complicated, and I didn't give you that one. But if we look, we did givens, we did the want, we didn't do the equation. The other steps that we didn't do would be algebra. And then we didn't do the numbers. But what's nice about this is we at least attempted it. And by doing that, we did 2 out of 5 steps. So if I was grading a problem like this, and maybe you had no idea how to do it, how many points would I have to give you? I'd have to give you 2 out of 5. Or pretty close. So I got 2 additional points. And let me show you how that kind of works. On this problem, we got 2 out of 5 points that we had no idea on. This problem, sophomore level physics problem, we had no idea, and we still got 2 out of 5, which is good. Number 3, we were perfect. We got 5 out of 5. Number 2, we got 2 out of 2. And number 1, we got 5 out of 5. So if this were a test, for example, if you added up all your points, there would be 17 possible points, and we got 14 of them. Which means if you calculate that, we're going to be in the B range. Which isn't bad considering that on the very last problem, we had no idea, right? So we did 1, 2, and 3 perfectly, but we had no idea in the last one, and we still ended up getting a B. Now what happens if we would have left that last problem blank? We didn't use the physics format, we're just like, I don't know, and then we put IDK, I don't know. We would have not gotten those 2 points, which means our final score would have been a 12 out of 17. And if you calculate that, that's going to be in the low 70s for a score. That means our score on this test would have been a C-. So that's the difference right there. So if you go through the physics format, and even on a problem you don't know, you can squeeze out a few more points, and we end up getting a 14 out of 17, which is a B. If you leave things blank, it really hurts you because it drops you over a full letter grade there. Alright, so we got to fill this sheet out, which we just did. We put our name at the top, put your hour on there, and then tomorrow we'll collect this in class. And then from this point onward, we know how to do our physics homework, whether it's a number problem, where we're doing give and want equation numbers. That's how we do the number problems. If it's a word problem, number 2, we always write complete sentences, and we're good to go. We'll see you tomorrow in class.